In this video, we're continuing with Chapter 11, which is on similarity, and we're talking about proportionality theorem. So this video is going to cover the triangle proportionality theorem as well as the parallel lines proportionality theorem. They're very similar. So let's take a look at triangle proportionality theorem. It says if a line parallel to one side of a triangle intersects the other two sides. So here's my line, and it's parallel to this side of the triangle, then it divides the two sides proportionally. So that means that this side of the triangle has been divided into these two pieces, and this side has been divided into these two pieces, and they have been divided proportionally. So again, with proportions, there's lots of different ways to write them. I'm a big fan of highlighting to see the different parts. So we're going to write this proportion in a couple different ways. So I'm going to first do it as green over green is equal to pink over pink. All right, so then we would have QT over TR. So that's the two green parts with the small one on the top. So small green over large green is equal to small pink SU over large pink UR. Okay, so that's just one way you could do it. So another way we could do it is I could do a ratio of the two smaller pieces to the ratio of the two bigger pieces. So green over pink is equal to green over pink. That will also work. So I could do QT over SU is equal to TR over UR. All right, and either one of these works. And again, these are just two of several different ways we could write the proportion. All right. Now the other part of this is going backwards. This is the converse. So now it says if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So for the first one, we knew these two sides were parallel, and then we could say that these proportions were true. Now we know the proportion is true, so since that's true, we know that these two sides are going to be parallel. So we have QS, segment QS is parallel to segment TU. All right, that's the triangle proportionality theorem. Let's move on to the parallel lines proportionality theorem. So this is a very similar picture, except that it doesn't meet at a triangle here. It very well could, but it doesn't. And in this case, we have three parallel lines. So we have 1, 2, 3 parallel lines. It says if three, it could be three or more. If three parallel lines intersect two transversals, so L and M are our transversals, then they divide the transversals proportionally. So I'm going to color code again. So I have a yellow piece and a yellow piece. And then down here I have a green piece and a green over there. So if R is parallel to S and S is parallel to T and L and M intersect R and S and T, okay, basically what we have here, we have three parallel lines intersecting two other lines. So let's do a couple different ratios here. So I'm going to do yellow over yellow going from left to right, and then I'm going to do green over green going from left to right also. So I have UW over WY is equal to Vx over xz, or let's do yellow over green on the left side and then yellow over green on the right side. That'll also work, again, as long as it's matching orders. So UW over Vx is equal to WY over xz. All right, again, there's several other ways you could write that. If you want to try one of those ways out and ask your teacher, that would be a great idea. If you have questions, make sure you get those answered, and we'll see you next time.